wonderful introduction, this fireside this morning. It's truly interesting. And welcome to this the second day of Mainstream and Global Wind Energy Council's conference on offshore renewables. And thank you for inviting me and the rest of our participants to talk about infrastructure. So that's what we're going to do today. My name is Christian Kjær. I work for a company called Supernode Limited in Dublin. And yesterday we heard a lot about all that wonderful equipment that's going to go up in the seas, the North Sea and the other bodies of seas in Europe. And Cameron Smith told us yesterday that the Scottish-UK goal means that we need to put up a gigawatt, I think every 10 weeks, you said. Roughly. And I thought that was a fascinating calculation. So I went home and took a rather conservative target from the European Commission and calculated how much would need to go up in the European Union in addition to that, and that's one every 5 weeks. So we're at 3 gigawatts every 10 weeks for the next many decades. And we do not have a grid. And somehow we need to feed all that electricity into something, and it has to be built in time for all that equipment to feed electricity to the consumer. So that's what we're going to talk about at this panel. The European Commission estimates that we're going to invest 800 billion euros in offshore renewables. 1/3 of that investment will be in generating assets, the stuff we heard about yesterday. 2/3 of that investment will be in grid infrastructure. And the reasons that 2/3 of those investments are in infrastructure is that there is no grid today, and that the price of the generation assets have come down quite dramatically. So that's a good thing. But it is really, the infrastructure part of this is very substantial. So I would like today to ask a couple of questions, and that I hope we'll have some answer to when we finish. How do we avoid that the grid becomes a constraining factor in that necessary development of offshore renewables? Do we have the institutional and political structures in Europe to make it happen? And if not, what needs to change? Do we have the technology and the engineering capabilities to meet one of those greatest engineering challenges of our time, to build an offshore infrastructure for all that offshore renewables? I would like to have answers to those questions addressed today. And we have a wonderful panel of policymakers, business practitioners, scientists, and I'll just shortly mention that here on the podium in Glasgow we have former EU Energy Commissioner Andris Piebalgs. We have Managing Director for National Grid Interconnectors, Nicola Medalova, and we have Dr. Eddie O'Connor, who is chairman of Supernode Limited. He is also founder of Mainstream Renewable Power. On a link up, and I hope we'll get a photo through to them, we have Professor of Energy Systems at Imperial College, Goran Strubac, and we have the chair of ENSOE System Development Committee, and also Director of Asset Management at Amprion, Gerald Kendler. They're going to appear on one of these screens, I'm told, when the debate starts, if not before. So the way we'll do this is we're going to have a keynote address, and followed by another presentation, and then we're going to have a debate about that keynote address and the presentation among all the participants. And I'd like to start asking our keynote speaker, former EU Energy Commissioner Andris Piebalgs, to take the floor. Andris he has documented success in policy making. Back in 2008 or 9, he was Commissioner for Energy, and he sat down and drafted the legislation that gave us the 20-20-20 by 2020 targets. Basically, we needed 20% renewables, 20% greenhouse gas reductions, and 20% efficiency by 2020. On the renewable side, we just learned a few weeks ago that we're at 21.3%. And mind you, we were at 8.5% back when your services put forward this proposal, and which was eventually adopted unanimously by the heads of states. So documented policy success, can we replicate that on building an infrastructure? Andres Piebalgs is also affiliated with the Florence School of Regulation, and that's an organization, Florence, that gathers a lot of thinkers on how we do energy regulations in Europe. And it's a very, very influential organization. And Andres did a paper on that, and he'll hopefully present some of the main conclusions on infrastructure related to that work. So, Andres Piebalgs.
Well, thank you very much, Christian, for this kind introduction. I am really honored to be here. When I got the invitation, I really was humbled, because always when you speak, you need to be prepared. So, nowadays, well, perhaps I have less such a type of speeches that I will deliver today. So that I would like to say the main message at the beginning, because later on I will try just to justify this choice. With experience and age, you also have some sort of intuition. When you look on climate change challenges, there are so many elements, so many figures. It's very difficult really to understand what's actually the most that matters. And for Europe, it's definitely offshore wind. For a lot of reasons that we have seen how it evolved, offshore wind seems critical element to achieve climate neutrality by 2050 or not. Because I'm not saying that there could be another technology that will evolve, but then you miss 2050, that's for sure. So I think that's where it is. At the same time, it is an area where you can't overinvest, or it will be highly unwise to overinvest. So that means that you need the harnessed energy to use wisely. And that would mean you need to transport it to the consumers in the most efficient way and where it's most needed. And we have some preconditions for this. So we would just need really focused deliver in this direction. And it's not only academia or policymakers, it's a bit more broader engagement, and I am hopeful that it will go in this direction. I have some indirect proof of it. If you look on the main reports that characterize European energy situation, it's called rather ambitious State of the Energy Union 2021 report. The subheading perhaps is less ambitious, I would wish more ambitious, contributing to the European Green Deal and the Union's recovery. And I was interested where they would put offshore wind, because it's not obvious that it should be high. Actually, it's quite high. And it's not you to discover new things, but I believe the people who wrote and the later who read, by instinct put it very high, because offshore wind strategy is not a huge event, and it is already in 2020. But the thinking is there. So that, I would say, is also supported by the people who perhaps are afraid so loudly to spell it out, but it's still there. And now I will try to move to give the context of the whole exercise. If we see main indicators of the EU, there are good trends. One is CO2 trend have been success. It's down by more than 30%. Well, you could always argue how much it is a carbon leakage. You can always argue also impact of the crisis. So it's a lot of factors. But basically, 20 definitely is down. With renewable electricity, with renewable target, Christian also said, final figure next year, but we have done 20.6 we not. But there is some caveat, and one is good, one is bad. The good news that is in the report, that first time ever, it's 2019, renewable electricity production in the whole EU is more than fossil. 38% is renewable, 37% fossil, 25% is nuclear. that with all the different approaches that we have, still you could have not argue that there is very limited emissions of CO2. So basically, you can imagine that you replace this 37% by renewables. It's not something that you can't imagine because the trend is there and you need to accelerate it. And it went by two elements that is mentioned. It is mostly by technical innovation, experience, and costs as a result came down. So that's the logical things that always happen. And it was before 2009, so it was roughly 2006. The expectations was that technology costs will come down. But at that time, it was a leap, because if you would like the costs should be coming down, you need to invest big, because then innovation happens on the scale that costs are coming down. And this gamble, or this guess, or this anticipation, I think more correctly would be say anticipation, was correct. It could be wrong. Well, then it would be quite an expensive mistake. But you do it on an educated basis. So these are a couple of good things. There are some other important things that we would need. EU market coupling has evolved, so now it connects all member states and connects and creates a common EU trading platform for electricity. So it's single day ahead. That's nearly done. So I think 1 or 2 borders left. Then single intraday is moving, and it's quite obvious that we are moving even to the markets of near real-time balancing. So it is immense thing for consumers because savings are immense. So EU electricity market with all the schemes that we have is moving reasonably well. Well, I could say that it's not so easy because there is a lot of litigation cases and also appeals to the Board of Appeal that I have chaired, but it goes in the right direction very clearly. Also interestingly is that most member states have achieved 15% interconnection target. Actually, they have done it quite well because with more renewables, you actually need to increase interconnection. So this also went better. Why it went better? Because I would discuss the secrets that there have been some money on EU level. On interconnectors, market is rather lazy to invest, and politics is always complicated. I would remember the case between interconnector between France and Spain, and it did not move. Public opposition was too much on both sides. And then we went there, talked with the people, we understood the grievances, and it went been done. There have been not any substantial problem. You needed some slight push that it goes in this direction. But there are a couple of real challenges, not even medium and long, but short term. Energy efficiency, so target is definitely will not be reached. Okay, was ambitious, but still I am really sad about it. So there are more structural problems that we saw. Public research and R&I spending is lower than in the year 2010. Net energy import dependency is 60.6, and no surprise that Putin says one thing and then everybody listens what he has said, because with 60.6% dependency, definitely is the biggest supplier. Even if you don't like what he says, you still need to listen to it. So you are also limited independence on it. So it is some worrying trends. And overall conclusion from this report is, I think, very wise. It says, about the trends, it still falls short of what is needed to drive the required energy sector transformation. So it's not wrong direction, but it falls short and it's require more stronger direction. From the FSR point of view, we looked upon the facts, because for me what matters this time is really time frame. We have not so much time as we would like. 100 years would be nice. 200 even better. We have 30 years. So we can't expect any fundamental new discovery. Physics has not changed. So whatever you do on the basis of physics. So you apply it, but it takes time. So you know basically what you have. There could be new things that could be used 2050, after 2060, you know, but basically you know where you are. And the answer is rather simple: decarbonize the electricity, because it's in the essence of so many things that you need to do this is the first step. Second, use electricity wisely. Don't lose on transmission, on the inefficient use. You need to use, I would say it's not every drop of electricity. Well, electricity is not quite dropping, but I can't find other good comparison. So you need to be wise in it, because if you are not, first of all, it costs more. But second, you have more problem with the infrastructure building. So public opposition is there. So if you need to demonstrate it. And for this to come, you need to identify and eliminate infrastructure and other bottlenecks that are likely to constrain the cost-efficient production and use of renewable electricity. So that means that you need to take these risks, what we talk at with renewable energy at early stage. You need to anticipate, and it is based on technology development. And why it in Europe, where it works? There is a good example. We have Baltic countries, and I'm citizen of Latvia, Lithuania, and Estonia. These three countries have been not connected to any European grid, only to Russia, with all the consequences that it is. And political speeches have been for 5 to 10 years, strong speeches, nothing really happens. No movement, because when it comes to concrete projects, then it's always something is in between. Not fundamental, but just a small. And we created so-called Baltic Electricity Market Interconnection Plan, where Commission was part of it. And today there is interconnector with Sweden, interconnectors with Estonia, there are interconnected with Poland, and with Poland they said they will never make it because Poles are not interested to get cheaper renewable electricity. Nothing that was true. But you needed really guidance in this. Yes, countries are involved. Yes, that's their project, but you need facilitator and also, well, mild mechanism how to sort out. There have been a European coordinator used for Polish project, so you need some type of support of these type of things. Otherwise, you are not successful. And I believe what the issue today is actually exactly the same. You need to find a mechanism that really supports building this grid, because you can't otherwise to expect to be successful. So, what are the additional things that help this development? One is European climate law. European climate law is rather strict, and I would say if EU is not successful achieving 2030 target, I would expect this case to land in court. What they will decide, I don't know, but there will be consequences. So there is no option not to achieve it because it's legally constrained. And that, I think, is an enormous thing. It's first time in history, well, second time, because we have now constraints that cases that countries have not reached renewable energy targets should be brought in front of European Court of Justice because they failed law. And that, I think, is quite obvious. Then we have delivering the European Green Deal package, or Fit for 55, with main elements ETS, 40% renewables, 36% of reduction of final energy consumption. It's comprehensive and honest package. I really believe in it. But the problem are 3,000 pages, time until you adopt everything, and then implement, and then check the implementation. You lose time. If you would have more 10 more years, I would say it's fine. So basically, yes, it will deliver, but we lose this momentum, and we need to do some other actions that definitely bring us in the right direction. But there is a very important sweetener. There is a public finance that are collected on the EU level with common borrowing. As you know, a lot of countries have been very negative towards it. But the response for the markets have been excellent for this one-off decision. And what I read in German media, that the government, that new government that will come, actually is looking positive towards such a type of mechanism using for particular purpose achieving climate targets. Because first of all, it gives cheap money to everybody and for this particular transformation. And second, it provides for more harmonious development inside the whole EU. So you have then the scheme of money that provided actually for this 15% interconnection, that provided also for Baltic states not being energy island. And this time it's on bigger scale. It's not done yet, but at least I don't see anybody now very strongly opposing it, because it makes sense such a type of historical transformation in Europe being supported by common financial instrument, and then you also have different accountability. Because the main weakness of current situation, I would call it, is too much emphasis on national energy and climate plans. No question they are important. Each nation should feel responsibility for it. But if you have 27 plans, plus you have recovery plans, plus you have national development plans, plus, you have too much of this. You really lose this in the plans, and plan is plan. And as I have lived in planned economy for quite substantial time to remember, plan not always really matters what happens on the ground. So that's a weakness of it. So you need to be more focused where you have more accountability and comprehensive plan, good to keep it, but it's not the main. And that's why this European dimension is so important. Again, I come to the starting point that wind is key driver. So renewable-based electrification, renewable hydrogen that's already announced, electrical vehicles, so and less intermittency with offshore brings this. So the targets are here. We have now offshore 15 gigawatts, 2030 is expected at least 60. National energy and climate plans are more ambitious, they say 84 gigawatts. 2050 it's 300, but it could be more. I would just say that Europe is definitely very strongly leading. And for first panel, for me, was important that people talked about supply chains. We are, in comparison with PV, strong in the sector. We have all the interest for climate, for jobs, actually, to keep it. And I would just give example from US. Overall installed capacity is 30 megawatts. Countries that is actually doing good, it's China. China is doing good. They will be perhaps in 2030 will be world biggest. If they will, well, we have big competitor, but I hope that they will be second largest, because we have nothing against that they evolve, but I believe that it is. And Bill Gates makes a very, well, it's for offshore wind in his new book, he has only one page, because nothing to be discussed. When he says, offshore wind holds a lot of promise. It's getting cheaper and can play a key role in helping many countries to decarbonize. So it's very, very simple statement. Take it, because there is nothing more to discuss, actually. Yeah. But it's clear that we need to acceleration. One is installed capacities. And here I think it's wise what is being also discussed, that this Maritime Spatial Planning Directive need to be looked upon, because there are many purposes. There are environmental impacts that need to be decided, but there is any directive. And Commission is preparing report, I believe very crucial report for wind industry for the March 2022 that will look on compatibility of plans with this Maritime Spatial Planning Directive, environmental protection and biodiversity in general. It's rather crucial, and they could add some more ambitions. I believe that this permitting situation, that is another issue that had been and delivered. So two RED directives, RED 2 and RED 3, already is moving things in the right direction. But Commission will provide also a guidance in 2022 how to tackle the administrative investment barriers by streamlining. And there is expectations that state aid guidelines at least will continue to be also in this respect technology specific, allowing technology specifics that you could have auctioning also of offshore wind specifically. So that at least it seems for industry is important. So if I see the elements that are slowing things down, they are or in process to be overcome or they basically are not existing. The real challenge is that we need to have a new approach of offshore renewable electricity and grid infrastructure. When you have very limited wind, it's rather simple. You have radial connection with all the consequences on the shore. That's true. But when you have more sophisticated, you need to go to meshed grids. And that, I think, is something that is in there. There's a lot of discussions about it. But still, we have not moved towards it because development and planning for an offshore grid needs to go beyond national borders. So it should be forward-looking grid investments. And it should be based most probably on intergovernment agreements. Expectation is that this could be done by 23-24 when national energy and climate plans could be adapted. But for me, as I already thought, that plans in itself, I think, is too weak instrument. And I would wish that by this time, Commission comes not only with blue plan, but some type of instrument that is based on discussion with member countries. And it could anticipate not like BEMIP, that was basically good cooperation, but more stronger legal framework. Because we will have no second chance to make it. We have only one chance because of the time, and because of the importance of the issue, and because of the cost. So I believe this direction is the one that I believe also Commission will take forward, but we all need to help it to happen. Because as any political body, even being well placed also understanding on technologies, you are still very vulnerable when you are being, well, not supported, at least by some audience. And I believe that for Commission was always important for renewables, that they have been audience or stakeholders that said, do this, because it is important. There have been a lot of people said, it's nonsense, you can't do it, or keep ETS price as a main instrument. But there is another part, and then you decide upon it. So for me, today's topic, indirectly, it seems a crucial element on the EU's decarbonization path. Should not be looked in isolation. It should be looked on combination, what we like to achieve, how we would like to achieve, what technologies we have, and where we have experience also to create a job. So I believe that's where we come. So it's not magical tool, but it is an element that connects different things together, and we have a lot of still needs to be done. So I will stop here, and I know that there are a lot of other elements related to the grid, how you share the costs, but that could be agreed in this plan, because we have good experience on difficult questions. There is a pole grid gas interconnector, and Latvia is not directly connected, but we also contribute to the costs of this grid because we also get benefits. There is methodologies that sort these things out. They're perhaps not perfect, but if there is a methodology, you could expand it. So there is no issues, at least at this stage, that I would see as an overcoming obstacle. So it's a great initiative. I really believe that it's crucial. And today is one of the events that leads to us really to have this offshore grid for Europe, for the world, and well, for us ourselves. So thank you very much.
Thank you very much, Andris Piebalgs. You said that Bill Gates had one page on offshore wind, and we should listen to him. Andris Piebalgs is one of the great energy policy and regulation thinkers in Europe, and he came with some suggestions, and I think we should listen to them. Thank you very much for that input. Bill Gates also wrote that if you had an optimal infrastructure when you build out renewables, you can actually avoid 30% of the capital investments on the generation assets. So there's a lot of savings in getting things right there. I'm going to now ask Goran Strubac. He's a professor of energy systems at Imperial College in London, where he is now sitting. He has been looking into energy policy and continues to provide the scientific basis, analytical basis for a lot of the decisions on energy policy in Europe, and has done it for decades. He has recently been looking into, together with E3G, what are the costs of all this grid that Andris is saying that we need to do, and where we don't have a clear plan yet. What's the economics of all that? And of course, that's extremely important. Although I heard yesterday evening that Tom Burke from E3G said that science trumps policy, policy trumps economics. Still, it is good to have an idea about what are the economic benefits of starting greater cooperation on building out this infrastructure. So, Professor Strubac, the floor is yours for the next 8 to 10 minutes.
Thank you very much, Colin. Much appreciate that I was invited. Apologies that I wasn't able to come physically. Hopefully this will work. Can you see my slides?
We see
them. You can, yeah?
Yeah.
Yeah, excellent. So as mentioned, this is analysis we carried out regarding the development of North Sea infrastructure to support cost-effective integration of offshore wind. And one of the core aspects which I'm going to kind of focus upon is to do with the need for strategic thinking in this area rather than incremental, and also to have a more European dimension versus a kind of country-specific developments, which is where the to be a bit negative, this is what needs to be overcome, and what are the benefits of this. This is just to show the analysis was focused on offshore wind project. You can see the dots in here. We won't go into details, but this is looking into the wind farms, offshore wind farms which are being fully commissioned or under construction, pre-construction, and so forth. Also including floating wind turbines, because there is now quite a big development and demonstration that this would also work. And in here you can see that in the modeling analysis there was 580 offshore wind projects, again given the data which we have created together with E3G, but also with ENTSO-E, and showing also that the scenarios. You can see that that the amount of offshore wind in capacity in terms of its 340 gigawatts on the this is 2050 medium scenario, but also high scenario, which is now quite a big on the agenda, is getting to, you can see, 490 gigawatts, and that also includes this 150 gigawatts of floating offshore wind turbines, which is also now big development. And also the as mentioned already, the load factors of offshore wind have massively increased in the last several years, from around, say, 30%, nearly double now, and also the floating offshore wind farms are getting above 60% load factors, which is obviously producing huge amounts, very big energy, and that's why the costs overall have reduced. And the question here is how we're going to do that, how we're going to integrate that cost effectively. And given the time scale, I won't go into, this is just a kind of showing what the assumptions were in details. but this is these are the results, extreme ones. On the left-hand side is if we connect all of the offshore wind, you can see kind of radially to the countries where the offshore wind farm is, radial connection, and also there is obviously some interconnection between the countries, but is not being linked with the offshore wind development. And you can see that in terms of on the right hand side is the fully integrated approach, where we look at the design from the kind of European PLC perspective, rather than kind of country specific areas. And there is a significant amount of offshore wind which is being connecting the different offshore wind farms, but also that some of these interconnections go via offshore wind. So you use the same infrastructure both for the exchange of energy between the countries, but also that goes to connect offshore wind farms. And this is where one of the core aspects is of this, which needs to be developed, which is what we called multi-purpose interconnection. Interconnection needs to go by offshore wind because you can make massive savings, but also connect overall this properly. And you can see that in terms of the costs, given the assumptions, and also there are some potentially changes in there. The costs maybe that in here, because it was looking to 2050, the costs were potentially at a lower end. But you can see that there is more than 55 billion in pounds savings if we do this in a integrated fashion. When we have an also strategic approach rather than incremental approach, when you are connecting now offshore wind, you should also think about what you're going to do in the next 10, 20 years, not only what's happening now, and that would have also significant implications on the network infrastructure, similar to what was, after the World War II, when when the decision was made to increase energy consumption order of magnitude, and then the strategic investments were, decisions were made to build, 400,000 volts transmission system, and that was the right decision, given that there was a significant development in decades after that. So we should have also in here strategic thinking, not only what we are doing now, so that we can make sure that the overall infrastructure investment in this is minimized. Just to show also that there is also quite what was demonstrated in this analysis, that there was a significant amount now of offshore wind, which cannot be fully used in Northern Europe only, electricity, given the assumptions regarding the demand and so forth, and generation. And there was and as you know, there is a significant interest in potentially then using these resources. This is what we're going to demonstrate. These resources in the North Sea, in fact, can also be used to actually support, for example, supply electricity demand in Southern Europe. But also there is also big interest in discussions about having this having the hydrogen, and we have done just an analysis showing that if we use hydrogen and we base the production of hydrogen offshore and then use existing gas infrastructure in there to ship the hydrogen where it's required, and versus doing only electricity, you can see there is also visible difference that it may be potentially going forward also to look at whether some of these hydrogen requirements could potentially be produced offshore. This wasn't going to the details about the hydrogen infrastructure in detail, but it's just was a high-level analysis to see, what are potential benefits you want to do it, where should be done, because if you produce it offshore, then you would need to invest less in electricity infrastructure, and you could potentially use, the assumption here was that we can potentially use the existing gas infrastructure which is under the sea to ship the hydrogen, which is a bit, optimistic assumption. But this is again just to show that we probably need to think about the overall system, energy system, not only for the electricity, because obviously hydrogen is going to play a visible role going forward. And this is just to show that there will be also potentially benefits on the infrastructure investment if we do that. This is just to summarize the modeling results. This is kind of, as mentioned already, just to provide kind of a bit of evidence which should inform how the intergovernmental policies and markets should evolve. So we can make, because this is currently very, very difficult, given the present policy and market framework. This is just showing that there would be significant in savings in the investment if we can have a full coordinated development, including also strategic rather than incremental. And the benefits are, you can see, kind of 55 billion in pounds given the analysis. This was the comparison between having this radial connection, which is what we currently do. We've got an offshore wind farm and we connect it to onshore. While having the integrated approach, you would think about, what is the overall approach, the context, which would minimize the total costs, and then you would potentially, link, for example, some of these offshore wind farms in different, in different areas in the, in the North Sea, in different countries, also specific, so you can have that. And this is also showing that we need to have, rather than country-specific offshore wind integration, to have a fully integrated offshore wind in the North Sea. And this is also showing that which currently doesn't exist, which is this multi-purpose interconnectors. And there is a quite significant, as you may know, in the UK, there is a, in the National Grid company which works on this, and there is a significant now interest to see how we can link the interconnectors with the offshore. And that is a important aspect. Also, from the broader European perspective, that currently, given again assumptions which are based from given with the discussion with number of including ENTSO-E and so forth, that the wind capacity and the energy produced in the North Sea cannot be used only in these in the Northern Europe. Again, because there is a much bigger growth than it was 5 years ago mentioned. And then this is just to show that in these particularly obviously with the high offshore deployment scenarios, which is nearly 490 gigawatts of offshore wind by 2050, and that this is that is potentially to be used in other parts of Europe. And if we could use that energy, both electricity potentially and hydrogen production, to supply that across Europe, would potentially be important to have in mind. And also this differences between producing hydrogen offshore or onshore with electrolyzers may also have implications of the overall infrastructure investment, both in the gas or hydrogen infrastructure, but also on the electricity infrastructure. So we do need this shift from the incremental country-specific to more global thinking, and look at the global approach to this. And that would obviously require, which is what we are going to discuss. I didn't include that because I just focused on the kind of evidence, and that definitely requires changes in the regulatory framework, in the policy framework, market framework. Because, for example, just that to have these infrastructure which would have a connection between different offshore wind farms and also countries, to have this multiple interconnection, is still to be fully developed in terms of the market regulatory framework. Thank you, colleagues. Sorry, a bit longer, but yeah, I will stop sharing.
Thank you, Goran. Thank you very much for that input. Let me bring in our three panelists, starting with Nicola Medalova. She's Managing Director of National Grid Interconnectors. So it's very appropriate she's on this panel. I'd like to ask the three panelists, starting with you, Nicola, to maybe address some of the things we heard from Andris Piepas and from Professor Strabac. I think at least they said two things where they agreed, which is something is not working on the offshore infrastructure side. We need to do something different, and that an integrated approach is absolutely necessary. Now, I was at a breakfast that National Grid held yesterday, and the Belgian minister, I don't know how many times she said it. I stopped counting at some point. It's like, we need to work together on this. And I know you heard it as well because you were there. But maybe your take on what we've heard from Andris Piepas and from Goran Strabac from a National Grid perspective, who needs to build infrastructure and are building infrastructure also to continental Europe.
Thank you, and thank you for inviting me here today as well to participate. Some really fascinating insights, Andres and Goran. I think from my perspective in National Grid, my job is to turn the real drivers that you've created and you've illustrated very well into reality and turn them into actual physical interconnectors that are in the sea. And so everything you have said, both of you, is incredibly encouraging to companies like National Grid. And we absolutely buy into it. And we absolutely want to have a coordinated grid in the North Sea. The challenges that we have are practical ones of how we deliver that now. And we know that, we all know a coordinated grid is the right idea. Some of the questions, though, that we have to answer is, who is the architect of that? And there's no, especially since we have left the European Union in Britain, there's no clear, obvious answer to that question. And until we address some of these big questions and we commit to whoever the architect is, and we all commit to that, and we take the huge benefits of the financial savings that go with it, we don't really have an opportunity to start building it. But we also know that we haven't got time to wait, because this is a critical decade for us. And so we need to keep building interconnectors. We are very far down the line in discussions with a multi-purpose interconnector with Belgium. We've just commissioned our North Sea Link interconnector with Norway. We're very keen to do another interconnector there. We're looking at interconnectors with the Netherlands, but there are some real stumbling blocks for us in that. The first being that we don't have, for multi-purpose interconnectors, we don't have a regulatory or commercial regime yet that allows that to happen. Although I was very encouraged yesterday when the government, BEIS and Ofgem, announced that they were inviting the next round of cap and floor entries next year, and that would include multi-purpose interconnectors. I think that's a big step forward. But I think the message that I would give is everything you have said is the right thing to do. The challenge that we have today is, how do we turn that into reality?
That's the challenge. Thank you, Nicola.
Yes.
I'm going to bring in Gerald Candler, who is with us remotely. He's the chairman of ENSOE System Development Committee. He's also director of asset management at Amprion, one of the large TSOs in Germany. And system development is really what all this is about, Gerald. And ENSOE is the European organization consisting of European TSOs, and you have a vast role in planning this. Some of your tasks including the planning and also infrastructure development, for instance, through the 10-year network development plans that you are the authors of. So from the view of European transmission system operators, could you provide us just with a couple of replies to what we heard from Goran and from Andris, please?
Yes, thank you very much. And first of all, it's great that I can join you remotely. It's technically very well done. I almost have the feeling to be there. Anyhow, I think if you want to be really sustainable for the future, you have to save energy. And there electricity comes in. Electricity is super efficient, and we have this huge potential of renewables. And we at NSOE believe by 2050, the energy demand could double approximately. And then offshore comes in because offshore has a huge potential. Social acceptance is there, and we have as was pointed out, the high full load hours. So it's really, really cool. But then everything comes together, as Goran pointed out. It's really system planning. First, you have this variable infeed, and then you need the other sectors like offshore, like transport, and so on to complement this. But now we go into the system planning, as Goran pointed out, and I fully support that we need a European plan, and not only to connect offshore to the land, but to connect offshore to the load centers and to interconnect the countries in between. And then there are a couple of things. First of all, NSOE is quite prepared to do the job, and the 10E regulation is setting up a scheme that could put us in a role there, and we are quite prepared to take it up. And I would like to point out one thing. This European coordination is really, it takes a lot of time. It is time consuming, but it is really important to have a truly European view shared by the countries, and then it will save a lot of time at the very end. And here it is extremely painful to see that UK is not part of NSOE anymore. The UK TSOs, because for offshore it needs to be a truly European initiative, and here I'm talking about geographic and not politics. There are two things that I would like to point out that are really needed. First of all, the technology that Goran pointed out is not there yet. At NSOE, in our research and development scheme, we said it's really important to have multi-vendor, multi-terminal, fully interoperable technology. And there R&D funds are needed, because this is going to be extremely expensive, but as Goran pointed out, fully with my full support, it's highly efficient. And also we need a good regulatory scheme, because we need anticipatory investments. We cannot only wait until it's done, we have to prepare well in advance. And also there's another policy issue in Europe. It's the 70% capacity that needs to be open for trade. It really hinders offshore development of the scheme that Goran pointed out. So I would like to say, yes, NSOE is fully prepared, but there is the need of further policy improvements to really make it happen. And that's support R&D. I think that's important. Have clear responsibilities, and also think of some supporting rules that support the integration of renewables and bringing them really to each customer. Thank you.
Thank you, Gerald. Thank you very much. And our last panelist is Dr. A.J. O'Connor. He's chairman of Supernode Limited in Dublin. He's founder of Mainstream and Electricity. I think you won the World Energy Policy Leader award by Scientific American and a bunch of other honorary and a lot of other things. You're out with a book called A Dangerous Visionary, and you've been on this travel through making renewables commercial since the 1990s, and you are now turning to the grid, trying to figure out how we are going to move all that now affordable electricity around Europe. So your takes on what we heard from Andres and from Goran, Eddie.
Thank you very much indeed, Christian, and it's great to be here. We got that award from Scientific American magazine in 2003 for our formulation of the supergrid, which we formulated in 2001. And the reason we formulated the proposition of the supergrid was I worked in the ESB in Ireland, which is the local monopoly, or was the local monopoly. And then I used to be a big sinner in those days. I supplied peat to the electricity system in Ireland, 5 million tonnes a year, releasing 10 million tonnes of CO2. So I had a big background in the electricity industry. And I thought, you know, we expect, when we press the switch, we expect to get the lights. And we can't do that with wind and solar. And in fact, in 2001, there was no solar, really. It was not commercial. So we said, I read a paper from the University of Kassel in Germany, which pointed out that the wind is always blowing somewhere. And if you imagine a storm, and all wind in Europe is due to storms that arrive from the North Atlantic, and it tracks over Ireland and England, Norway, Belgium, Holland, all the way up to Finland. And if you could capture the wind all along that pathway, well then, what the generation would look like would be something like this. As the storm came in, you'd go up, and then because you captured it along its entire length, it would look like firm power. And that's what led to the formulation of the supergrid initially. But then I didn't realize at the time, because just, you know, I didn't realize it, I was silly, I suppose. We're going to build 900,000 megawatts of offshore wind in Europe. We're also going to build 900,000 megawatts of PV around the Mediterranean basin. And these two great weather-based systems have to be linked up. So we actually can't decarbonize in Europe unless we do this offshore wind, and unless we have a meshed offshore grid, which Andres talked about, and pointed out the absolute necessity for this. So from that humble beginning of trying to even out wind, to the situation where we now are absolutely dependent on this for decarbonisation, this is where the supergrid is at today. And I have to say, you know, Gordon Strabich put on a map there of a meshed offshore grid. We've been working with the University of Strathclyde here in Glasgow, and some various researchers there, professors, have been looking at how do you do a meshed offshore grid in DC, because it has to be in DC. You know, you can't put AC underground. It just builds up huge resistance. So it has to be a meshed offshore DC grid. And they looked at what happens if something fails here or fails here. And in fact, they have demonstrated quite clearly that you can do this. This is technologically, this is fine. And so the latest endeavor that we're at is we set up Supernode. We're using superconductivity, which will actually result in the cost of the grid being taken down by a factor of 50% when we get it. We're at TRL, Technology Readiness Level 3 at the moment. By 2025, we'll be at Technology Readiness Level 6. This is a joint venture between Aker and myself, and the great Aker company from Norway, which recently bought 75% of Mainstream. We're determined that we will provide the underlying technology which will allow Europe to decarbonise. I can't see how we can do it without that. I'm absolutely, and to address the question that Nicola raised there, how do you govern this stuff? How does this all happen? And I tend to think that, you know, Norway and England and Scotland, of course, and the 27, the rest of us, forget about, you know, political blocks and that. England has a coastline of 700 or 800 kilometres in aspect onto the North Sea, where it can be, along with Ireland, the leading producer. Norway can come in as well, but you know, like that's maybe a little farther away, but it has got cracking wind speeds. We'll get 65% capacity factor from floating wind off Ireland, off Norway and off Scotland. And we have to join all that stuff together. So we could go on for a very long time, but
we have until 11:15, because I know that Andres Piepas has to leave for the blue zone, but we have another 15 minutes.
Well, I'm not going to talk for you know, like I'd love to hear other people's opinion. This is a voyage of discovery. We need these countries to get together with Europe. We need a governing body at European level, including the rest. We need a governing body which will say, where's the first leg going to be built, and subsequent legs, where will they be built? How is this going to be charged to the customer? There has to be an architect who will actually work at that kind of thing. And you know, we are going to, and we're working very closely with the European Commission at the moment to bring about that governance structure. because it's not just good enough to develop the technology, which is going to take the price down by 50%. We actually have to have an appropriate governance structure. And we're actually, despite Brexit, we're all Europeans. And we need to work together. So I'll stop for now.
So we need an architect. We also have a volunteer for who that architect should be, Gerald. How would you structure that? And I'm going to ask Andres Pipas afterwards. Based on history, can we do something at European level to create a structure in which we can build interconnected, well-coordinated mesh grids and reap all the economic benefits that Goran is saying? So it's a question to all of you. Who would that architect be? I'm going to start with you, Gerard, because you suggested it should be NSOE. And that is a debate that has been going on, and there'll be there has been responses on that as to whether it should be someone with ownership interest in the grid itself. But your view on that, Gerard?
First of all, the TSOs are all regulated entities, so there is also the regulators that have a very good look on what we are doing. Secondly, I think the TSOs are the most neutral players because we are regulated and we have an interest in keeping the lights on at low costs. And we have a good track record. If you look at the TYNDP, our 10-year network development plan, it is a unique plan. There is no plan similar to this anywhere in the world. Not even the US has a plan that spans the whole of the US. Don't talk about a plan that covers about 30-some countries and 40-some TSOs. So we have quite a good track record, and to getting this together in cooperation with the UK TSOs, our friends there, I think that is a task that can be taken on. And I think the first step that we need to do is, as we do to identify the system needs. I think they were pointed out by Goran, for example, to show where they are and then see what technology there is. There are also some very encouraging TSO initiatives, and now I'm talking with an Amprion head. We are a member of the Eurobar initiative, and the Eurobar initiative has the objective to standardize the future offshore platforms so they become offshore grid ready, so that you don't have to decide now, are you going to connect it, yes or no, but you're going to make the offshore platforms ready so that when it makes economically sense, you connect them. And you see all those encouraging elements. And I think the key issue in Iowa is coordination, because you save a lot of money, you save a lot of time if all those planning, all those initiatives are really coordinated, and that is really.
Andres Pipas, do you have suggestions on how we structure these things, and how do we do the institutional framework for setting something up that ensures that we can coordinate towards a meshed DC grid?
Well, it's anyhow something new. I believe the best starting point would be definitely intergovernmental agreements that gives some type of frame for it. It's not that I underestimate experience that regulators or system operators have, but it's a huge enterprise. You need to make a framework. It could be very simple framework, no question about it, but you need to have that UK government, EU government, and Norway is, if it decides, or somebody else who would like to, is committed to it, and how to proceed. And then to learn from the experiences we have. I mentioned very small experience on this gas interconnector, but you know how dividers. So then we have experience now with Baltic synchronization with continental European grid. Again, small drop compared with what needs to be achieved. But there is a learning curves, initial, who invests, where invests, what methodologies have been used. So I believe that, first, intergovernmental agreement would be needed. You can't avoid it. And second is learning from the experiences we have, where complex tasks have been solved in ways that everybody was happy at that.
But Nicola, do you have enough? It's clear that we need to make a framework that allows you guys to make anticipatory investments, as many have said here. Do you have the tools there? And if not, how do you actually make investment decisions these days? And how do you see, what, from your perspective of being the ones that are building the grids, do you have the technology and do you have the framework for making those anticipatory investments for servicing all that offshore renewables that all the scenarios now are saying we will have?
On the technology, I'm much more optimistic than I am on the framework for anticipatory investment, to be perfectly frank. So I think, you know, for the kind of interconnectors that we're looking at now that are picking up wind farms or connecting to energy islands, we pretty much have the technology. It maybe needs to, you know, to go that next step, but by the time we're there, I believe the technology will be there too. The framework, that's different, and I agree with Andres. You know, intergovernmental agreement between the UK and EU is absolutely the right place to start. However, that's not going so great at the moment, and I don't know how long it will be before we start to have. We've got such a backlog of things that we need to resolve, and energy is, you know, it's being used as a bit of a pawn at the moment in some of the challenges in the negotiation. So I think we have to get there, but I also think government, you know, government won't take the architect role, and I think, you know, I think Gerald has you know, he's right. The TYNDE, the TYNDP is something, you know, it's fascinating. It's I think it really works, and I think it would be a great starting point. However, I can't ignore the fact that we're no longer a member of NSOE. And being able to relay some of the challenges from the UK in the decision-making process for that architecture is really critical. We know that when we have all this wind coming in by 2030, that we could have 100 new landing points on the east coast of Scotland and England. That's just phenomenal. Now we won't be able to consent that. That will be the blocker, and that's why the government's, you know, really keen on collaboration and coordination between interconnectors and offshore wind, so that we can, you know, reduce that burden on coastal communities. But I don't know whether, with all due respect, Gerald, you know, I don't know whether how well you understand some of those UK challenges to be able to trust that an organisation that we're not part of can then deliver the architecture for the North Sea, and we have to commit to that. So I do wonder whether there needs to be something new and different that's established for this, that starts with intergovernmental agreement, but then has all the major players, including the UK, with a seat at the table.
So Andres put his point up, and then
just
Gerald.
the idea was brilliant intervention here, but I think we have one issue that we know. UK has now planned for 20, 30, 40 gigawatts, where they would like to place. EU countries have also these plans. Then you see on the map where they would like to put, and then you try to have this more simplest radial connection, and then you know you can't make it. So then you try to optimization task, and then you come to reasonable technical solutions that also politically is affordable. And I read also that, not big surprise in UK, the biggest challenge actually to connect on the shore, because people say don't dig there, don't cable there. So you need to have as little landing places as possible. So that's very obvious. But I think it stems from the wind energy development plans. That's where, as I said, grid will deliver if there will be will and financial means. The challenge is on that side, and governments have taken it. So let's then optimize the grid.
Gerald, very
Ich bin gerade in der
short comment.
Konferenz wieder rausgehen.
Could you repeat that?
Okay. I have a very good and bad news at the same time. I fully agree with Nicola that the technology is more or less there. Not fully available yet, you cannot order it, but we will get there by the time we need it. I think together with industry, we'll need some efforts. We have to install it big time. It's not there in industrial size yet, but we'll get there. I also believe that the planning engineers of the UK TSOs and NSOE can cooperate very well. I don't think this is a big issue. They give us the freedom and we will do it. However, the framework to have an overview of what we do by the British regulator, by our regulators. This will be difficult. I think it's really a framework issue, and it's there. I have to fully agree with Nicola. This is going to be the big challenge, to provide a framework where we can actually work.
I saw Eddie O'Connor shaking his head when you said that the technology is there. I know his CEO at Supernode keeps saying that this presumption that the grid technology is there is wrong. I assume you have the same opinion, Eddie. Or do you,
well, absolutely.
Why is the technology not ready in your view?
Well, I mean, there isn't enough copper in the world to connect up 900,000 megawatts from offshore to the. And even if you opened up new copper mines, they take 10 years to get going. And I'm not even sure that that's there. When you use superconducting materials, you use about 100,000th in terms of weight of what you're using with copper. But just back to the architect question. I think the last people in the world who should be the architect are NSOE, and I'm not insulting NSOE or National Grid. You need an independent regulator, an independent system operator, just like the MISO in America. Right from Manitoba in Canada down to the Gulf of Mexico, you have got MISO, the independent system operator. They don't own any assets, so they can make decisions which they don't have a vital vested interest in. Where if you have just a collection of, let's say, people who own assets, well, then there's going to be constant battles as to, well, should you own it or should I own it, and where will we run the next one? You need an independent system operator in Europe who will sit there and work with the TSOs. I mean, the TSOs are indispensable. They're going to see about a 250% increase in the demand for electricity, so they're going to have to concentrate on how do you get all that extra power to the customer, because every car and every house is not probably going to be heated by electricity. That's the main point. The governance should be organized in terms of, a representative from every country, I would think, on a board with the chief executive. But as part of a subsidiary of that would be this independent system operator who would be able to plan where's the next.
Sorry, may I step in here?
No, very briefly.
I know I'm impolite, but but if you look that we don't have a US grid development plan, whereas we have a European one. If you look at the disturbances, if you look at the interconnectivity of the US, I think there are many things that really talk for our European system.
Right. We have 5 minutes we're 5 minutes left, and I'd like to give you the opportunity to ask your question. Please tell us whom the question is for, and please introduce yourself down here and here. Do we have there's a microphone coming.
Thank you. My name's Gareth Davis, and I'm down from the Orkney Islands. So some of you might be quaking in your shoes at that point, because the Orkney Islands and Shetland and the West Isles sit at the heart of Europe's most renewable energy resources anywhere. And I've just listened and watched and seen how these resources are still isolated from the plans that people are speaking about. And when you were saying, and I'd love to speak to you afterwards, Nicola, about who's going to be a champion for this. The islands are ready to be the champion. We've been standing there for 2 decades saying, connect us, connect us, connect us, because we know the resources are there. So in addition to all the other things that you've spoken about, I would just say, think about the communities that are wanting this to happen and engage with us. We're ready.
Thank you.
Excellent.
Good, with volunteers we have 2 now. We have the Orkney Islands and we have NSOE. Excellent. And we have a question over here, or a comment. I'd like it to be a question. Could you present yourself also?
Yeah, okay, sorry. Max Karkas with Sustainable Marine. I don't know how I follow that, Gareth. I was more of a kind of nerdy question, which was really about the challenge of capturing the value in interconnectors. And the existing interconnectors that exist between countries are very much kind of bilateral deals as I understand them. How can you get a simple model that explains what the financial benefits are so that everyone kind of moves forward with this? Is there a back of an envelope thing you can put down and sort of say this has been a good template for interconnectors, so you can inform this sort of discussion? Because capturing that value for the system of reliability is quite a difficult thing to put a value on, but it's clearly a really important thing. Thanks.
I'm going to direct that question to you, Goran. How do we capture the value?
Yeah, I mean, on one side is that we need a market. You know, one could argue we need a market for interconnection, which currently doesn't exist. UK is the only, National Grid is the only, you know, interconnected developers which works on the market. That's not done anywhere else yet. That would be kind of, but that is a big challenge. And the other one is what was discussed, to try to find out kind of what are the plans for going forward. And you know, are we going to have a kind of centralized planning, or are we going to have a market-driven development? And this is something which is you know, there is no yet clarity as to how we should move this forward. You know, but there is, for example, in the UK, the ESO, electricity system operator, is now in charge of doing the planning in a way to support the you know, from the UK PLC perspective, what are the investments. So what was mentioned earlier, you know, that if we had a kind of independent planner for the entire European transmission, particularly on the offshore wind, you know, that would also provide useful information. But there is still not clarity as to, you know, whether this is to do with the you know, you've got a market which would provide incentives for the, you know, for the companies to do the right thing for the UK PLC perspective, and that is, you know, for the European perspective. That's where the problem is. The present market is not aligned with the objectives of the European system. So it is a big challenge in that context.
Thank you, Goran.
So you know, so if anything goes wrong, it's Gerald's fault. Okay.
I would have liked you to respond to that, Gerald, but we are simply out of time, and I know that some of you panelists need to leave, so I'd really like to thank you all for a fascinating debate. There are a lot of things we need to do. We need to find an architect. We need to also figure out how we do some agreements intergovernmentally, and we'll come back to all those questions, and we didn't answer everything, but we certainly managed to put some of the main stumbling blocks that needs to be addressed on the floor here. So thank you to Andres Piepas, Goran Strabas, Nicola Medalova, Gerald Kendler, and Eddie O'Connor. Thanks for coming.
Thank you.